All right, thank you for coming. Well, thanks, Alex, for the introduction. So my name is Rachid Zarouali. I work in a French company called Senolia. I am basically the CIO. I manage ops, basically. We do a lot of Docker stuff since 4 years now. And we also do consulting for our clients to help them learning how to use containers. You can have my Twitter and my Slack IDs, my email, and the logo that you have just below is the company that I just founded, which is basically based on helping ops and devs to learn the same tools, to learn containers, and basically to not do what I will show you, or what I'll try to show you today with containers. Our agenda is based on most of security, host security, image management, container security, and we will talk about a few open source tools that we can use to help us in this container journey. But before introduction, security is always a side. In every project that I've seen, security is not the real concern. The problem is, security is not the problem of the ops or the devs. Security is the problem of all your teams. And they should handle the security all together in the same way so that when you put containers or apps in productions, you won't face some issues. In the ecosystem, we have a lot of partners. There are some, and what you have here is some of the well-known one, Aqua, New Work, Twitlock, Sysdig, and there are many more. The thing is, if there's that much company in this ecosystem that grows and that started to focus on security and containers, probably we have an issue. And I tried with several side projects that I've learned to see how people are started to use containers. And what I've seen is not really that good, because what you have here is some bad habits that I see, and I really saw them in productions. People were trying to mount Slash into their own containers. People were trying to add all the capabilities into the containers because the application they used was based on systemd. Systemd needs all the capabilities, so on and so forth. So we have a problem, and I think that we have a problem, and this talk is basically based on giving you the basics. It's a back-to-basic talk on how you can secure your host, build the right image, and how to use them so that your devs and your ops team can push them into production. Another bad habit that I see is this one. People were using Apache, it's fine, but they say, oh, I forgot, I miss MySQL, I miss PHP. I don't care. Let's open it and let's install it in the container itself. Probably the worst one that I've seen is the latest one, is that people are doing full upgrade in the container itself. So they see the container as a full operating system, which is not. And in the security topics, there's a lot of aspects. In Docker view, you have image building, you have signing. Signing won't be a part of this talk, but I'll be more than happy to talk about it in the backstage this afternoon. You have vulnerability scanning so that you can see if the containers you built is vulnerable to a known CVE or any issue that you can have on a very specific version of a library. Docker Content Trust is a tool that is aligned with image signing. It's a tool that you can use on your host or on your CI/CD system to sign image so that you can see who built this image, who signed it. And you can also follow the flow to see where this image has been pushed into production, and if the image that has been pushed into production are the ones that you really wanted to. Into the Linux space, there are a few that you have over here. There are Linux capabilities that you can use to give more power to your own container. For example, you may need to do traffic capture. So you will have to do the netbind capability to your container so that you'll be able to do it, so on and so forth. The two latest that you have on the slides are SecComp and OpArmor. The latest one is a security model that you can load into your container, and it's by default activated nowadays into the Docker engine, and the other one is seccomp. Both of them are using, how could I say, configuration files, JSON-based, that will filter what your container will be able to see and what your container will be able to do on your host. Seccomp is filtering syscalls. All the syscalls that your container will try to access, Syscomp will filter them so that you won't be vulnerable to hacks, probably in your application. And Alpha is more on the system itself. It's more like the Ubuntu way of implementing SE Linux. How many of you are running containers into production and are using any or probably more than one of these features now? Please raise your hand, just to have a quick overview. Okay, it's going to be fun. All right, back to basics. What are containers? Basically, containers are nothing. Containers are just namespaces and C groups. So basically, there are resources and limits that you can use and put into the application. As long as you don't put any data in your container, it doesn't exist. And the access namespaces are to allow you to access several features or several resources on your host. C groups is here to limit them so that you can put limitation on CPU, memory, disk, network, IOs, so on and so forth. What you have on the next slides is just an overview of namespaces and C groups that are available when you're using containers. I won't go too much in that. Any questions now? All right, let's go. So, speaking about Docker host, today you can deploy Docker on whatever the Linux system you're using. There's always someone who has built the package for Fedora, Ubuntu, Debian, Arch Linux, so on and so forth. And there's also some operating systems that I really liked that are completely container-based. The idea of this operating system is to offer the smallest operating system that you may need to run your containers into production. Some of them that you have over there, Atomic, CoreOS, Rancher, and Linux, are ordered by size. The first one is the bigger one, around 100 megabytes. I'll show you later, and so on and so forth. Atomic OS and CoreOS that I will talk about briefly right after are on the merge. CoreOS has been bought by Red Hat, and there are projects to merge them. Atomic OS is clearly Kubernetes oriented. It is based on Fedora, and they have integration into Cockpit and OpenShift. Who uses Cockpit? OpenShift? Ah. Those of you who are using OpenShift, have you or are you now using Atomic as a container-based system? Or if not, what are you using? Red Hat, perhaps? Red Hat Enterprises? Okay, so it's probably too much for the system just to hold containers. We'll see. CoreOS, everybody here knows CoreOS, right? Yes, everybody knows CoreOS. I think they still have their own container engine, Rocket, which has been used by a French company named BlaBlaCar. They do, there's the French Uber, if I can say, like that, so that you can travel around. Aside of Atomic, CoreOS has a way of managing the system that it's, I think, tricky. You don't have the same packages that you can have in Atomic OS that you grab off the Red Hat repository, and is there some, in my own point of view, issues in using the system. The one that I really like, because I think it's really well-based and well-made, is Rancher OS. Anyone have ever uses Rancher OS? 1, 2, 3. Okay. Rancher OS, as all the others, is completely container-based. But a very funny idea and a very interesting idea of this operating system is that you have different container engines. There's one for the system itself, which is completely based on container. I will show you right away. And there's another one that you can use to deploy your own container. And it's completely separated. The containers that have been used to build the system can be updated using some internal commands. And the container that you will use for your own production are completely in their own namespaces. There's no overlapping. There's no way that a container from the system like DHCP or UDEV or so on and so forth can interact with one of your containers. And the latest one over there, whoops, is LinuxKit. LinuxKit is a project from Docker in the Moby project itself. It's a very, very, very shrinked system. As you can see, the footprint is very low. It's clearly system developer oriented. It's probably the most efficient, but the harder to use. You have to build your own system. You don't have, as Rancher or in Atomic, commands and tools that is the way that you update the system, add features, and so on and so forth. The idea behind LinuxKit is to really have an immutable OS. Your system has been built. You have an images, an ISO that you can use on your platform, on AWS, on Google Cloud, so on and so forth. But there's just no way to modify this system on production. It's completely unimmutable. The idea is very interesting behind this because as it is immutable, you won't face probably most of the issues that you can have on Red Hat system, on Debian system, Ubuntu, and so on and so forth. But managing it should be prepared and constructed so that you'll be easily switch from versions to versions, because switching to version is switching to the OS itself. There's no like in Debian or Ubuntu system apt update, if I can say. A little bit of things that I saw at my previous experiences, and let me just switch. All right, there we are. Everyone can see? In the back, it's okay? Perfect. So I have a system that I've seen in the infrastructure of a friend of mine, which hosted some WordPress platforms. And one of these guys, what he did is that by the time that he discovered the containers, he says, oh wow, it's very interesting, let's put them on production. But what he forgot is that, well, basically the system where he deployed Docker has already some platforms into production. So what we did is we were looking to see how the, oops, -B is better. All right, so what we can see is that on this machine we have a Docker engine, that listen to the 2376 port. Let's see what we can do. Demo1.jazoon. This isn't funny. Yes. Should be better. I forgot to pray the demo god. So please make the demo working. Okay, what we have here is clearly an engine that's listened to the request. What does that mean is that the engine has been modified. It has been configured to open his API clearly on the internet or in the infrastructure without any encryption. The simple fact that I can query just information about the engine means that there's no security built in it. So probably I could do something like this. OPT into, let's say, Alpin minus ty. There's Wi-Fi, right? Should be. Or I think I have to switch to another images. All right, the image is up. What do I have? Okay, let's do this. Okay, so it seems that I have completely access of the file system. Let's see if I can do something like I shouldn't use demos. Groups. Okay, seems the demo god isn't with me today. Awesome. All right, this one is screwed up. Anyway, probably the other one will be working better. So, put it simply, what we had is that as we had access to the Docker engine, we had access to the whole system, and having access to the whole system, we'd be able to do whatever we wanted. We could deploy crypto miners, we could deploy, I don't know, some database. And for those who were using quite a decade for now, the FTP servers that we can find on the internet to grab several illegal software, we could at least do the same. I mean, we could have easily deployed an FTP server and do whatever we wanted. What we had to do to fix this is that to use the TLS options. But by using TLS options, the Docker engine uses mutual TLS, which means that you authentify the Docker engine and the Docker engine authentify yourself using certificates. Honestly, I wouldn't advise you to do it in your own way. There are several tools that are available. One has been built by a friend of mine, which is HBM, that you can find on GitHub, which is a Docker authorization plugin that have some tools to generate for you all the certificates that you use and that you need for your Docker engine and for your ops or your devs teams. The idea of this kind of security options and plugin is that you can allow specific person to have access to the Docker engine remotely without exposing the engine itself over the internet and facing some issues. So let's speak about images. There were some talks about it earlier, so I'll try to do it quick. Docker images. So you've seen that you use the Docker files. They're based on containers, and to use them, you can use Docker run and every options that you have. Basically, what are Docker images? Docker images are layers put all together to create your image. The image is on read-only, and when you start your container, you're creating another layer which is in read-write, and in which you can write your data or the logs or whatever the ID. But writing a Docker file, and we had a great talk in the beginning for that, is the more layer you have, the larger the image you'll have, and the slower to build your image you'll be. Basically, every layer that you use will slow the build of your image. What we can do then is use base images as much as possible, which means sharing the images between the containers that you want to use. Limit data written into the container, drop whatever is unnecessary, and chain run containers. What you have here is two examples that I grabbed from the talk of Abby Fuller from AWS, and they show the way that you can optimize your container. I won't go further on it. We have quite a few before. Basically, what we can do is use multi-stage build as much as possible. We had a quick overview right before. And to make your images as small as possible. The idea of having small images is to limit the surface of attack, which means that you won't embed in your images, development libraries, tools that you may need to, see the processes that you don't really need in production, so on and so forth. What I can show you, if it's working, is one images that you can use, but with a bit of optimization. Let's see if this is working. Is that okay for everyone? I hope. Is that okay, even in the background? It's okay. So I borrowed this Docker file from a friend of mine, which when he'll see this recording, he will probably laugh or not. We'll see. What we have here is that we have a LAMP stack that is built into the Docker files, and we have many access. As you can see, we're using the same command in different steps. The image is made. The Docker file, is made to install every packages depending of your dependency, so on and so forth. What we can do is doing probably something like this. So what we did is we removed all or most of the run commands that we have. We shrink them into a single one, and at the bottom we just drop all the cache, because IPT cache is not needed in a container. It's not needed when you build an images. You need it when you create your images, but when you push this image in production, you don't need IPT cache. So we just basically drop it. We made this image so that all the configuration files that you want to change will be in the end. Because if I change this command, it will trigger all the commands below, and it will rebuild all the image itself. Imagine that, for example, I have these commands which change the time zone in the PHP configuration file is at the top. Whenever I want to change the time zone, at the top, it will rebuild all the images. So the idea to have it below is that, okay, I will install everything that I need, every packages, every tool that I need in my image, and in the end, I'll modify or I'll push configuration files only. What we use here, is there anybody here using Tiny? 1, 2, 3. Tiny is an init replacement. There are others, dumb init, for example, which has been built by Yelp, the company Yelp, as far as I remember. These small exec files are used to trigger all the kernel calls that you will have with the PID1. Who have never heard about the PID zombie? Everyone has heard of it. Cool. This kind of stuff limits this issue by listening to all the kernel calls and just pushing the right one to the application it will trigger. I can, if you want this afternoon, we can talk a bit about it and how these tools helps. Whoops. On figuring out. Another thing, pushing images in the registry or in the public registry by just overwriting the tag. I'm pushing, I don't know, the version 1.1, and I've seen that, oh my, I made a mistake. Oh, no worries, just push another one and override the tag. If by any bad luck, someone get access to your registry or your public registry account, you can easily create another images which will have the same tag, but with a different content. The idea of using digest is to have all the layers that has been hashed, and the hash of all the layers has been generated. The digest is this. What it makes this image immutable, so by pulling an image using the digest, you make sure that it is exactly what you want to push in production. I can easily, if I get access to your registry, I can easily create an image with the same tag, with exactly the same name, and push it into your registry. And I challenge you to see where the bad guys would have broke your image. Who's using digest to pull images? Okay. Going on. A funny thing that I'd like to show you is we have spoken about registries. We hear good. All right, so this machine. Okay. Home Vagrant. So on this virtual machine, I've already been authenticated into a private registry that I used. So my credential has been written into the config files itself. So what I should have is this, and this is, as you can see, an insecure registry. It's locally on my machine, by the way. What I try to show you is this. Base 64 dash. Got it. So the credentials are not encrypted on your system. What does that mean is that you should, and there are tools that have been made for this, used another system to store your credentials on the system, on your host, whether it's in your laptop, whether it's in your CI/CD system, on whatever the host will build your images. Don't store credential this way. Anybody who has access to it can do the same as I did and grab your ID. And as I said before, change your images, because it seems that none of us today are using Digest to pull images. What you can use is a tool that a friend just showed me a few days. Docker credential helpers that you can find on GitHub. If I have Wi-Fi, it works. This is another and very simple way to store securely your credentials on the system. What you can use is GPG. So you are creating a private GPG key, and your credentials will be ciphered using your GPG key. Even if I have access to your system, I should then have access to your GPG passphrase to get your credential. So hopefully you won't leave the credentials on your system in a flat file. If you did, then I probably can't help you anymore, but we tried it with a friend of mine a few days ago, and it works really well. It's very simple to use. I can easily share on a GitHub repository how we did and how we uses it. It's simple, secure, and you won't have probably the little bit of issue that I show you just before. Okay, now that we talked about the images, I want to be quick because time flies. About running your images. Yeah, I'll try the question. Who ever runs a container in production using -- privileged? Be honest. 1, 2, 1. Who knows what this kind of option means? Definitely. All right. The idea behind is to use container without using your root account. If a container is started as root, then being root on the container is being root on the system. If you run as root and you're mounting / then you can do whatever you want. You can screw the system, you can install whatever you want, even if you are using containers. And I really saw it in production. Some people were just, okay, I don't care, I just have to push it in production because we don't have time, and okay, we are using containers. Containers are secure. The engine is secure, and by default, the Docker engine is secure, and there are several methods and features that have been built in so that you won't face security issues if you're using containers the right way. And that's exactly what we have here. The example that you have here, I also saw it in production. People were saying, okay, I have to get access to the Docker engine. Okay, give me the sudo account. Let me do some sudo and I'll do it. The two commands that you have here are very simple. I really advise you, if you never uses it, to do it for all your developers or all your ops teams. Don't ever allow one of your coworkers to have access to sudo with the whole power behind just to manage your Docker engine. People were having some nightmares a few weeks before. What you have here is a very simple issue. If you are using root and mounting /, I can drop your system easily. I'm root in my container, which means that I'm root on your system. If I mount /, I can drop your system. Or worse, I can install a very skinny and tricky crypto miner so that I can have bitcoins thanks to you. And I'm sure you want that happening. An easy way to handle this is by using this kind of command, using --user, and by specifying the ID of an unprivileged user. You can use it on a compose files. You can even create images that runs and started as an unprivileged user. I highly advise you to do it. You can, and this is not in the topic of this talk, you can use root images. But to be secure, you will have to deal with other features that are more complex to use, like LSM modules, like AppArmor or SLinux, or even harder, seccomp. If you are not used to this kind of tools, don't run your containers on production as root. That's simple as that. Let's see what I can show you. Just to be funny. Oh yeah, this one is fun. Oops, losing focus. All right, darker images. What do I have here? Several. Okay. Darker run -it alpine dot 7 bash. Yes. Got it. Yes, I have the D. Even if you're using some features, there are some options that I also advise you to do and to use in your system is to limit the resources. I've spoken briefly in the beginning of this talk is how to limit the resources that your container can have access, because easily I can do something like this, which all right. So I have access to it, and I'm in my container, and I haven't used any limitation. I easily created a 1 GB file, which means that I can easily completely use your space and make your production system broken. An easy way to circumvent this is to use this kind of options. Oops. I love demos. All right, let's try with a new one. Docker run -it alpine sh. I'm not good at demos. I should have known that. What I just wanted to show is running your containers as an unprivileged user is fine. Running your containers with the right Docker file is fine. But it doesn't mean that nobody can break your system. What I just showed you by creating a simple file can be easily done with CPU stress tools that uses all the CPU resources that you have in production. And I can easily fill up your disk by just using the same command that I just showed you. If you are using containers in production, do please put limitations. Because if you don't, then your container will have access to all the resources, all the CPU power, all the memory, and probably all your disks. And as I tried to show you at first, it doesn't work. If your system isn't currently configured, I can have access to it, and I can break your system easily with just a very simple command. Seems we're right on time. So, who has learned something from this talk? Cool. Awesome. I mean, I made this talk because of very, very things that I've seen using friends, using companies that I'm helping, or the students that I'm teaching in French engineering schools. And I was thinking how this talk can be useful, and I'm very glad that it will be useful. So to conclude quickly, what we learn here, use the smallest OS as possible. If you have the skills, do it. Red Hat is fine, Ubuntu is fine, Debian is fine, Fedora too. But as I showed you at first, if someone has put in productions, applications, or middleware on top of the system aside of your Docker engine, then you're probably facing vulnerabilities. What we learn here also is to optimize the image size. Well, optimizing is very simple by following best practices. And there are many best practices on the internet regarding how to write a good Docker files. There's a simple tool that I just want to advise you to use is Adolint, or Adolint, I think. Don't know exactly its name. Which, as its name says, whoops, it does linting. So it helps you to make Dockerfile as good as possible. And finally, we learn, or we see how you can secure your production images by not using tags, but using digests. And we also see how you can securely store your credentials without having them just encoded in base64. If you have any other questions regarding this talk, regarding probably a more advanced features, I'll be more than happy to answer them now, or you can join me in the backstage station this afternoon.
Thank you very much, Rachid.
Thank you.
Round of applause for you.